Test.
I can hear you.
Recording. Yes. Guys online, can you hear me?
Yes, I can hear you online.
Perfect. All right. So good morning, everyone. This is lecture number 14. Amazing. And we're still in chapter 2, which we are good on schedule. We're supposed to spend really large portion of the course on chapter 2 because it's covering a lot of basics that you're supposed to take most of those basics in another course. But yeah, anyway, we are really on schedule. For today, we'll try to complete chapter 2, finish it, and move on with the next chapter. For today, we will practice a lot with Karnaugh map. You still remember what is Karnaugh map? Okay, perfect. All right. As I said, we are chapter 2, the last section, and we are covering logic gates for this chapter. And what is the purpose of Karnaugh map? Alex? Excellent. To simplify Boolean equation or to get the most simplified version of this equation. When it was introduced? Excellent. Almost there. 1953. And it was introduced by Maurice Karnaugh. And this use as tradition. Whoever introduced a method, they call it with his name. So this is something great. Imagine like your name is there forever, for hundreds of years. Everyone is using it. Hopefully for good things, not bad things. Unfortunately, the scientist already passed away 3 years ago, 4 years. However, his influence or the impact of his method is still until today. You can see a lot of active research paper until today. Try to improve Karnaugh map. Try to change the way we need to implement these things or try to improve it for a higher number of variables. Now, let's see an example of how we will build Karnaugh map for 2 variables. So let's assume any 2 variables. Someone give me 2 variables. Any names? C and F. Someone got the highest premium markers. They're not erasable. All right, let's see. C and F, right? Okay, so how to build Karnaugh map? We said really the number of cells in the table depends on how many permutations that we can build for those 2 variables. How many permutations you think? 4, 6. Who says 8? Can you show me those permutations, please? Come. Hurry up. Yeah, start from 0, 0, all the way to the end. Let's see. Not the truth table, just go with the permutation. So F could be 0, right? C could be 0 as well. And then what else? Go ahead. No, don't draw the map. Just start with the permutation. What kind of permutation we will have? What kind of values C and F could take? Yes, 0, 0, 0, 1. No, there is no 2 in binary. 1, 1. And the third one, we are missing the value of f. What could be? One zero, yes. Where are the 6 values? 6 permutation. No. So this is 1 permutation. 2, 3, and also f could be 1 and c could be 0, right? So 0, 1.
Oh, okay.
1, 0. Called permutation. Okay. All right. Excellent. Thank you. Then now we want to build the Karnaugh map. So we want to have a table with 4 cells, 4 entries. How we could draw that map? We want to build a table with 4 cells. How can we build it? Excellent. This could be one option. Could build a table equally as a square, right? Could have this little sign over there to divide the variables. And then where do you want the C to be? Top. Excellent. We have C, we have F over there, right? And then what could be the values of those? 0, 1, 0, 1. And how to interpret this, how to read it, this first, this second, or this first, this second, how to read this cell, the table. This one will be 1. Let's use different color. Raise your voice. 1, 2, 10, 3, 4. Excellent. This is one way to build that table. This is the K-map. How do we know the number of cells? Based on the permutation. What are the possible values that we can assign to these 2 variables? Please close all laptops, all distraction, everything. Unless you use it to transcript, or if you are a businessman, you can keep it. Okay? Yeah, please focus here. So we know that we need 4 cells based on the permutation that we have for 2 variables, right? Now someone could say, how about building this table? At the end, we need just 4 cells. How about doing it this way? Right? And then could have the 2 variables over here. We have CF. So what could be, let's use the same color. 0, 0, 0, 1. Excellent. 1, 1, 1, 0. Why 1, 1, then 1, 0? Excellent. We all the time, whenever we move from one cell to another, only 1 bit is allowed to be changed at any time. Doesn't matter where we are. If we are here, want to move here, we only change that bit, right? If we are here, want to move to the beginning, also this one is different from this value by only 1 bit, right? And this is the nice property of Karnaugh map. Okay, so this one and this one are exactly the same. How to interpret the table? How to read it? Which cell is first? This one is first. 1, 2, 4, 3. Excellent. So if we have a truth table, this is the first row on the truth table, second row, fourth row, third row in the truth table. Okay? Right? Let's see it together. So whenever we have 2 variables, then we have these options to draw Karnaugh map. Okay? Now let's go with more. I want to go, oops, with 3 variables. With 3 variables. Someone give me 3 variables. Let's keep them. X, Y, Z. Excellent choice. I want to go with X, Y, Z. Okay, stay with me. How many permutation can we build out of this? 2, 8, 3, 2 to the 3. How many permutation can we build? How many possible way to assign values to these 3 variables? Remember, in binary, there is nothing except 0 and 1. You cannot have any other number. So either this one will be 0 or 1, right? But to make it more organized, we say always start from all of them as 0, right? 0, 0, 0. And then alternate over here with single bit. So 0, 1, 0, 1, 0, 1, 0, 1, right? Keep going until maybe forever. You'll see now until when. Here, alternate with 2 zeros, 2 1s. So this is 2 zeros, now 2 1s, 2 zeros, 2 1s, and keep going. Over here, every time we add to the power 2, to the power 2. So here, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on. So 2 to the power 2 means 4. So we need to alternate with 4 zeros and then 4 1s. Until the last row all filled with 1, we stop because we are going to repeat ourselves. Okay? So until here, we arrive to all of them 1s, done, stop. Now, how many possible permutation? 8, which is 2 to the power number of variables. Whatever we have variables over here, 2 to the power of variables will give you number of permutations. You don't need to think about twice. How many variables I gave you? 2. 2 to the power 2, then 4 options. How many variables? 3. 2 to the power 3, 8 options. Done. Okay? Now I know my table size or the K map size. It would be a table with 8 cells. Okay? Now how to build those 8 cells? Yes, Ali. Want to come? Yeah, please. Hopefully everyone can see this portion. Okay. Which color? Yes, yeah, if you can use, but we don't want to erase. Let's keep them. All right. Please pay attention. This is extremely important topic. You are going to implement it soon in your project. And probably I'll ask you to record the video, all of you, to explain your project. Okay? It's up to you if you want to post that video on YouTube. We can post it in our channel. If you want to keep it private, we can keep it private. So Z is one variable, right? How many options? Okay, perfect. And how to interpret? Maybe you can use another. How to read the table? Which cell is first? Please pay attention. 1, 2, 3, 4, 5, 6, 7, 8. Excellent, excellent, amazing. Thanks a lot, Alex. All right. So that is a K map with 3 variables. Okay. Is there another way to have a table with 8 cells? So for 2 variables, we see different ways. How about here? Now, if we move, for example, these 4 blocks to here, it will be as if you flip it. Then we'll have 1 variable over there, 2 variables over here. However, if you do that, then you might mess with these numbers. Then it will work. It is correct. But when you move from truth table to this, it will be pain. Why? Because you need to read all the time these 2 variables with this and get a number. And based on that number, you could check which row in the truth table. However, if you do it this way, it's automatic. This is the first row, second row, third row, fourth row, fifth, sixth, seventh, eighth. Done. You don't need even to read what are those values. You don't need to worry about them. You just interpret the truth table right away based on those indices. Okay? But it could work. You could shift this z over here, the xy over there, which I don't recommend. Always start with the first variable at the top. Try to keep 2 of them here and the rest in the other side, for example. We will see with more variables how it goes. All right, so there is one way to do with 3 variables, only this way, okay, which is highly recommended. Over here, you see those figures, by the way, are adapted from the paper of Karnaugh itself. So if you go there, you'll see a lot of those tables. He give you a lot of examples with different variables. And over there, he used something different than the way we explain it in the class. Okay, so you can see A to the left side, and then B and C to the other side. For us, we said the opposite. We said A and B to the top, C over here. The way we are using is another research paper, try to improve what Karnaugh was using in the past. Okay, so it's better to use this way because it's directly mapping the truth table to the table right away. You don't need to think about it. Over here, you need, yeah, we have 0, 0, 0, then this one. But over here, it will not be number 2. It will be something else. And you need to look into that in the truth table. 1, 0, 0, where is it? Try to find where is the output, and then you assign the value over there. All right, now let's go with 4 variables. Someone give me 4 variables. Can use the other side. Excellent. I think the blue is not working, but let's see. Want to try? A, B, C, D. Yeah, come here, please. Which color? No, blue's not working. The other side. No, the other side. Yeah. A, B, C, D.
Yeah, but this one where at least one.
No, you need to do that anyway. You might not need to list all of them, but at least know how many permutations do we have. Excellent. So now we need to build a table with 16 entries, 16 cells. So you need to build a table with 16 cells in it. Excellent. We divide the variables. We start with the first 2 at the top and everything else at the bottom. Now, since we have 2 variables at the top, then how many cells we can have? No, we have 2 variables at the top. 2 variables only, A and B. What are the possible options? What are the permutations for 2? 4, right? So we need 4 cells at the top. And this 1, 2, 3, 4. Excellent. Now, how many variables to the left side? 2. Then 2 to the power 2. Also, we need 4 cells horizontally. 1, 2, 3. I need 1 more. 4. We don't need the things to the left side. And you can erase them. And that is 4 by 4, which is 16 cells in the table. How do we know it's 16? We said how many variables do we have? 4. 2 to the power 4 is 16. So this is how we know that we need 16 cells in the table. All right, now what would be the first cell value? Maybe you can use red, as we did with the other tables. Keep it. Excellent. That's the first natural permutation. Excellent. This is the only trick in Karnaugh map. The third value should be 1, 1, not 1, 0. And then we jump into the third one, 1, 0. And now how about CD? Pay attention, exact same trick we have over here. So we start with 0, 0. Excellent. Amazing. So pay attention always to the trick of 1, 1. It's not the last cell. Normally in truth table, we have it very last. Over here, we should have it as the third cell. And we mention why. We are allowed to change only single bit from one cell to another. We're not allowed to change more than one bit. It doesn't matter if we are horizontally or vertically. Exact same trick. Now, how to interpret the table? How we fill the truth table over here. So we look at the truth table. The first entry always 0, 0, 0, 0, 4 zeros, right? Because we have 4 variables. Okay. Excellent. So you go with A, B first, and then C, D. Now you can stop here. Now what we are filling is the output itself. What you have over here is the input, right? So you have A, B, C, D. You combine them as 4 bits, and you try to fill, right? Those are the input. What we are trying to do over here is the indices of the output in the lookup table or the truth table, okay? So that would be row number 1 in the truth table. What is the output? And then we have the value over here. So you could just write the indices, and later on, if we have the truth table, you could just add the value over here of the output. We don't have the output here, but it's good that you are combining the input, but we don't fill it in the K-map, okay? So you need to raise them now and just tell me what are the indices of each of the cell. And those indices, we will use them to check the truth table and get the output from the last column, and then try to fill them in the K-map. Indices. It's plural of index. Okay? The index is the number of row in the truth table. Okay? So when you build the truth table, this is input, right? This is the output, could be, I don't know, maybe W, right? So this is row number 0 with index of 0. 1, 2, 3, 4, 5, 6, all the way to 7, because we start from 0 over here. So 0 to 7, right? So we go to row number 0 or 1. Over here we start with 1. Okay, let's keep it 1 to 8. Row number 1, what is the output? Whatever the output over here, the value based on the question, we have it over here, okay? We will see an example on that, but let's start step by step. Now we are just building the K-map. We are not solving it yet. We'll go next with solving it. No. You can use this, for example. You always start vertically in the first column. Remember the story? 1, 1, then 2, then 3, then 4. Remember this trick? That will cause us to jump from here to here. 5, 6, and then 7, 8. Excellent. When you combine those two, as you did before, when you combine 1, 1, and 0, you'll see that this is the second last. When you combine 1, 1, and 1, that will be triple ones, which is really last. So this will be the last cell to fill over here. Now we start with the same logic over here. 2, 3, 4, 5, 6, 7, 8. Remember the trick? Yes, excellent. But now you did a little thing. Remember the trick exists horizontally and vertically. The trick of 1, 1. So you need to do a little thing about the third row. No, start with 1, 2. 1, 2, 1, 2. There is 1, 1. Then you need to skip and jump. Yes. Remember, the trick exists at the top and at the bottom. So same way as we jump over here from 1, 2, 3, 4, and then we jump into here. Likewise, you need to jump vertically over here to the last row, and then go back to the third row. All right, 1, 2. No, jump. Skip this. Skip this. Jump 3, and then go back. 4. Yes. 5, 6. Jump. 7, 8. Go back. Excellent. Now again, jump. No, skip this. 9, 10. Jump. 11, 12. Now go back to the third column. 13, 14. Jump. 15, 16. Excellent. Remember, those are the indices. Okay, we are going to check this index and go back to the truth table, check what is the output, and then we fill it in the table. Okay, so we are not done yet. Now, if you are ever in doubt, about those indices, what we need to do? Yes, the truth table, we have it, but how to map those numbers, the indices, on the cells? The exact same way you did in the beginning, the first one, which is combining the variables and convert them from binary to decimal. That will tell you the index directly. You don't need to think about it. For example, pick any cell. This one, what is AB?
1, 1.
1, 1. What is CD? 1, 1. What is that in decimal? Pick another one. This one. 0, 1, and then 0, 0. Remember, this is 1, 2, 4, 8, 16, and so on. This is how we convert from binary to decimal. Do you still remember? So what is this in decimal? This is 4, right? Why we have it 5? Because we start counting from 1, not from 0. So you see the first cell is 1, right? That's the only difference. So it's up to you if you want to count from 0. You could go that way. But always, always remember that this is the first row, second row, third, fourth. If you want to go with those numbers, that will be translated into 0, right? 0, 0, 0. And then this will be number 0, which is first row. And then 1, which is second row. And then 2, which is third row. And so on. Okay? So there are 2 ways. It's up to you which one you pick.
That means that if we start by counting from 1, that all of them steps are going to be off by 1.
No, even the 16, because 16, when you start from 0, it will be 15. So this one is 15. 8 and 4, right? 8 and 4 is 12, and then 2, 14, and then 1, 15. So this is 15, not 16. So all of them will be offset of 1. Don't get confused. Whatever those indices, it means the row location in the truth table. Okay, so we start from 1, 2, 3, or if you want to start from 0, 1, 2, 3, exact same thing. But remember, we jump over here because we have this trick that we skip the first value, and then we go there, and then we come back. Likewise, if we have it vertically, it's exact same story. 0, 0, 0, 1, and then 1, 0 the last, and then we come back into 1. Yes. Excellent. Thank you. No, I prefer this method. Whatever I'm teaching you. Thank you so much. Right? I always prefer going with this way, because anyway, you're not going to have those numbers over here. You're not going to write them. It's up to you if you want to write them just for helping you to solve. But what we are going to write in those cells, something else, which is the output based on the truth table. Now we are just building the K-map. We are not solving it yet. I'm just trying to give you the idea based on the variables, how we grow this K-map. Okay? Is it clear? We didn't take one variable, by the way. So K-map with one variable, what would be? What would be? 2 cells, excellent, because 2 to the power of one variable, right? It will be 2 cells. Then how we draw it? It's up to you. You want to draw it vertically or horizontally, right? And then we have one variable, so possible 2 options, either 0 or 1. Remember, we are solving in binary, so this will be 0 or 1, or 0 or 1. That's it. But who's going to build K-map for one variable? You cannot simplify further, right? And that's the whole purpose of K-map. So we cannot build K-map for one variable. Doesn't make sense. We're not going to simplify it. Imagine the equation is something like y equals a. And I ask you to simplify it. Then you cannot build K-map for that. Yes? 4 variables like that? 5 variables. Excellent question. We will see it now. I prepared a slide for you. And that is the limitation of K-map. We will see it soon. OK. Again, as I told you, I copied those figures from the paper itself. This is the link. So in the paper, everything explained as 2 variables. We start from here, A, B, and then C, D at the other side. But there are a lot of research papers showing that you should start A, B in the top, and then the other variables at the bottom. So please follow this method when you solve. This is much better, much easier for you, even to fill the truth table over here quickly. This is not wrong. Again, this is correct, perfectly correct. It's up to you how you split those variables over the sides. But it will give you some pain when you go to the truth table and you try to fill those values on the K-map. Okay? Now, the valid question, how we go with 5 variables? First, 5 variables. How many permutations? 2 to the power 5, right? And that will give you 32 variables, 32 permutations. So we have 5 variables, 32 permutations. Okay? Now we need to build a table with 32 cells. Now K-map said, don't do that. Once you arrive to 4 variables, stop. And consider that as a building block. As a building block. Don't grow over that. And now, every time you want to increase more variables, duplicate that shape. So this is 4 variables, the whole thing. If you want to go with 5 variables, make this 2 copies. If you want to go with 6 variables, make it what's it for? Excellent. How do you know that? Excellent. Then the total is 4 times 16. That will give you the total number. Excellent. That's 4 copies, not 2. Okay. Now we will see an example. So this is K-map saying whenever you exceed 4 variables, don't make the table bigger. It will be a mess. Okay. Just make copies of this shape, the exact shape. The more you increase, the more copies you have. The number of copies is based on that each building block, each copy of this is 16 cells. And then you divide the number you get from this equation, 2 to the power number of variables. Divide that number you got from here over 16. That will give you number of copies. Okay? So number of copies of this building block equals 2 to the power number of variables divided by 16, because we have 16 cells on this table. Why we do that? Let's build for 5 variables. He simply says, and we can use green. You can consider this table. For example, first let's assume the variables themselves. Let's keep it A, B, C, D. Then we add one more variable. A, B, C, D, E, right? E. Now he said, we consider four of those variables to be included in the copy. For example, A, B, C, D, all the time will be inside the copy. A, B, C, D, okay? And then get whatever left over, which is E. And how many permutation we could have for E alone? 2, right? Which is either E equals 0 or E equals 1. That will be for the first copy. This will be for the second copy. So you make the whole thing with E equals 0. What does it mean? It means when I'm reading, interpreting this cell, for example, what does it say? It says 0, 0, 1, 0, 0. Okay, this one will be. So remember, any cell is represented as A, B, C, D, E. We have AB 0, 0. We have CD 1, 0. And the whole table is represented as E equals 0. So this is 0. Okay. And likewise, when you have the other copy, if you read a cell, E will be 1 all the time. Okay. However, when we try to build this kind of copies, take the first variable out instead of E, and then the last 4 variables, consider them for building the table. But here, for simplicity, just we consider E. Why is that? Because in the last column in the truth table, you will see that we will have, for example, if we have 32 permutation, you will see 16 times as zeros, all of them 0, 0, 0, 0. That's the last column to this side. And then another 16 as 1, 1, 1, 1, 1, 1, right? And that makes sense that all those remain as 0. And then we have a copy out of that. And then all the ones, we have another copy. If you cannot imagine it, I have it here for you. Okay. Those will be the 2 copies. Consider with E equals 0 and E equal 1. Yes. Yes, exactly, exactly. I'm going to visualize it for you now. That's excellent. And now when we have 6 variables, then we'll have, as we discussed, 4 copies. And we consider 2 of them fixed all the time. So we fix E and F, right? We fix it to 0, 0. And then we build for 4 variables 1 copy. For example, if you want to read this cell, what would it be? We have AB, so 0, 0. And then 0, 1, 0, 0. Excellent. Okay? Now we keep going. Yes, please. Excellent. You could do that, but it will be more complex. You'll build a huge table. This one easy to manage. Okay? How did I break it? Okay. So this will be way easier for you to draw, way easier for you to solve, and less probability to make mistakes, because really small area to handle every time. Okay. Hopefully we went gradually from K-map with 2 variables, even with 1 variable, which doesn't make sense. Please don't do that. I give you an equation like that. Don't build K-map for that. This is the most simplified form, right? You cannot simplify further. So this is with 1 variable. This is with 2 variables. We said there are 2 ways to draw it, this or that. And then we went for 3 variables, this one, and then 4 variables. And then we have 5 variables in the previous slide, and here with 6 variables, and so on. Keep going. However, it's recommended to use it only up to 6. If you go with 7, it's really going to be a huge effort, and it's way more complex than using the theorem that we use in the past. That's why we still have the theorems, and we have the K-map. None of them is the best all the time. Okay? So if we have more variables, better to go with the theorem. You could solve it way quicker, way easier than building many k-maps for those kind of equations. Okay? All right, now hopefully we build it. Hopefully everything is correct. We understand what we are doing. Now let's solve it. We didn't solve yet. This is a reminder for you that whenever we see a value of 0, 0, or any of the input, right, then the equation for that cell would be a not of that variable. For example, we will see that, but if we try to simplify and the output here was 1, then we need to build an equation for that cell because the output is 1. Then we look, if the input is 0, then we directly add a bar to it. For example, here, A, B, both of them are 0. Then we will have A, B, bar, bar, because 0, 0. And this is based on the sum of product, which is our default. Okay. Here we have C, D, both of them 0, then C bar, D bar. And this is how we represent this cell. This is not something new. This is what we discussed last time on min terms, right? Whenever we have zeros in the input, we just add a bar over there. Just this is a recall. If you forget this, go back to lecture 9, try to rewatch it. Okay? Now this is, I asked Gemini, can you visualize the reason why we have 1, 1 in this and then 1, 0? And this is the reason, actually. You can really think about it as a donut shape or torus. And this torus shape allows us all the time in going in circular motion. Whenever you go, you keep going back and forth, back and forth. For example, from here, we change only 1 bit, to here 1 bit, to here 1 bit. Also going back is 1 bit. However, if you look at the 4 by 4, here 1 bit, 1 bit, 1 bit, but also going back is changed by 1 bit because 0, 0, 1, 0. So the 1 is changed into 0. Likewise, if you go vertically. So here to here, 1 bit change. Here to here, 1 bit change. Here to here, 1 bit change, but also going back, 0, 0 to 1, 0 is also change of 1 bit. So when you visualize that, you'll see really the K-map is something like this, which is allowing you to go back and forth all the time. And this is extremely helpful in solving the K-map. We will see that now. You remember how we solved the K-maps? We took 2 examples last time. We look for the ones. We look for the ones whenever we have in the output ones, and we try to group them. We try to build a group out of the ones. Any one should be at least in one group. At least, not at most. Anyone in the K-map should be at least in one group. Okay, that's the first rule. Each circle must span a power of 2. By a circle, we mean a group. So any group should be of size to the power of 2. So it could be 1, which is 2 to the power 0. Could be 2 to the power 1, 2 to the power 2, 2 to the power 3, and keep going. So if I saw someone highlighting a group with 3 ones, that is extremely wrong, because 3 does not belong to this range. So either it could be 1, 2, 4, 8, 16, and so on. So any circle you would make, it should have this many of ones. So if I highlight any group in the K-map, should have either single 1 or 2 ones or 4 ones, 8 ones, 16 ones. Okay, this is extremely important. Each circle must be as large as possible. What does it mean? If I have the option to highlight 4 ones together in one group, don't highlight 2 of them separately. Okay? The largest is the better, because you are going to reduce the number of groups. You are going to make the most simplified equation. If you go with the list, like every two ones, you highlight them separately, then you're going to increase the number of terms, and that will give you a not simplified equation. Yes, please. Excellent. 2 plus 2. Why not 2 plus 1? Excellent. So every single point over here is extremely important by itself. We will see a lot of examples. I prepared many examples for you. Hopefully, it will speed up the things. Yes, please. Same question? Amazing. Okay. A circle may wrap around. A circle, by circle we mean a group. When we group the ones, may wrap around. What does it mean? If we have one over here and one over there, we could group them. Why? Do you remember the donut shape, the torus? So this is really as if it is connected to that side. So we group this one and we group that one as same group. So those two would result in single term, not two terms. When you build the equation like this, you only build one term for these two ones. Don't say, oh, this is A, B, 0, 0, so A bar, B bar, C bar, D bar, plus this one is A, no bar because there's one, then B bar, because 0, and this is C bar, D bar. This is wrong because this is not simplified. Why? You could take B bar, C bar, D bar as common, and then you lift out with A bar plus A, and we know that this is resulting in 1. So this is the most simplified version. And you did this mistake because you considered those separately. But you could group them, and then you would result in only single term over there. We will see all of those mistakes. But hopefully remember those rules. Those are extremely important. I could include them for you maybe in the exam. Maybe it's a good idea to have open book, especially for the table of theorem and for those things. For those things, like, you need to remember them. There is no logic behind it. You cannot think about it. This is what he invented, right, in the paper. The first one over here, we already solved it last time. So hopefully you know now how we fill the truth table in the K-map based on those indices. We said go to row number 1. What is the output? Output is 1. So just fill it over there. And then we said this cell has an index of 2. It means go to row number 2 and pick the output, fill it over there. And then here is 3, 4, 5, 6, 7, 8. And then keep going with the exact same order we have it in the red over there, and then try to fill those. So the final, keep going like that. Remember the trick over here. So we jump into here, then here, and then here, then here. Exact same way as we did over here. And we got the K-map filled with all those numbers. Okay. Now how to solve? Remember the rules. First, we need to group the ones. Where are the ones? Excellent. We have only 2 ones. So is 2 anywhere in this range? Yes. So we could go with a group of 2 ones directly, right? So we could group all of those together. And I will show you later on, but this is what we are grouping, right? And then now when we group them, any group should be represented by a term. What could be the term for this group? Remember, the entire group is represented by a single term. Last time we solved this one, so it should be easy, straightforward for you. First, we look where are the common things. So both cells are represented by A, B being 0, 0, both of them. And when we look vertically, this one is represented by C being 0, and this one is represented by C being 1. So it's not common. So we start with the common things. A and B are common in both of them. So it's directly, we say A, B. But remember, A is 0, Then based on min term, sum of product, whenever it's 0, we add a bar. So A bar, B bar. Now we look at the vertical side. Anything common? No, then just ignore. And that would be the equation for this question. This would be the most simplified version for this truth table. Anything common over here, 0 and 1? No, nothing common. Done, ignore. Because if you consider them, you would come up with the exact same situation as we have over here. You could take common, then simplify this with 1. Yes, please. All right, we have a lot of examples. Hopefully the time will help us over here. If you're ever in doubt how you'd solve this, I have the other table filled with all the terms that are possible. For example, this cell is represented by this term, A bar, B bar, C bar. Why all of them with bars? Because all of them with 0, 0, 0, 0. Now let's see another one. For example, this one, A, B, C, without any bar because the input are ones, all of them, 1, 1, 1. So this would result in 1, 1, 1 with no bars, and keep going. You don't need to build this. This is just for illustration. What you need to build is only this guy. Remember, what we fill over here is the output, not the input. The input would be at the top. These are the input. Okay? And now those are the output based on the last column. And what we need to look for are the ones in the output, which is exactly how we solve in sum of product, if you remember. When we build the truth table, we go with the ones only, and we try to get the min terms. Okay? Now this is the answer, A bar, B bar. Okay? This one we already go through it last lecture. Now let's go with a new example. So I want to build again a K-map with 3 variables, which is this guy. Okay, we just build it. Hopefully it's clear. If any question, please ask directly. This is how we build, so hopefully it's clear. Now let's fill it. We didn't fill yet. How we fill it? Remember the indices in red. That will tell you number of row in the truth table. So row number 1, which is the output. Yes, look at the output. Excellent. Let's use a color. So that will be 0. Now, where's number 2? 0. Where's number 3 here in the K-map? Over here, right? What is number 3 in the output? 1. Excellent. Number 4? Over there, the 4th row is 1. Where is 5? Remember, we jump. Excellent, because the 1, 1 here in the middle, so we have to jump. So where is the 5th? 0. Number 6? 0. Number 7? 0. 1. Excellent. Now, remember, by default, sum of product, even if I don't ask you, sum of products means look for ones. Look for ones. Where are the ones over here? 3, 4, 8. Excellent. So we have 3 ones. Can we group them in one group? Those are the number of ones are allowed in any group. Could be a group with single one, a group with 2 ones, a group with 4 ones, a group with 8 ones, and so on. So there is no 3, there is no 5, there is no 6, there is no 7. Don't invent. Okay? You are only allowed to build a group of this size, of this many of ones. Since we have 3, what should we do? We go with the largest group possible. What is less than 3? 2. So we go with a group of 2 ones. So how to group them into group of 2 ones? Want to try? You want to build a group of size 2 out of this. Which color? Okay. Yeah, now group 2 ones for me. Just try. You have 3 ones. You have limited options. Pick any 2, group them in a circle, or oval, or rectangle, anything. No, just look for ones. Yes, excellent, excellent, correct. Group them, draw something around them. Yes, keep going. All of them, yes. Excellent. Now we build the first group. We grouped 2 ones, we paired them. We left with one, a single one with no group. We need to assign it to a group. We cannot assign it to the same group because there is no 3. So it should be in a separate group, a separate circle.
Okay.
But wait, now we have single one. Can we group it in alone by itself in a group? We could, because we have a size of 1. Yes, we could do that. But remember, there is a rule says go with the largest possible size. Can we go with 2? Where? Can you group it in a group with 2 ones? Remember, a single one could be at least in one group. At least, not at most. So the same one could be in 2 groups. The same one could be in 3 groups. The same one could be in 4 groups. Doesn't matter. At least in a single group.
Okay.
So now group this one with any of those 2 ones. Which one is the closest? Excellent. Amazing. Excellent. Okay, as simple as that.
Okay, I wasn't sure.
Now wait, we are not done yet.
Okay.
We build the groups. Each group will be represented by a min term. Can you draw now the min term? Oh no, this is not working. I should throw it. Now look at the first group, first circle. Which one you want to pick first? Okay, this one, vertically, what do you have at the top? Input. Excellent. Yes, write it. A bar, why with bar? Because there's a 0 at the top, right? So there's a 0 and then B. Now look vertically with the same group. What do we have? The variable. No, look at the green stuff. Yes.
Oh.
We have 0 and 1. Anything common between 0 and 1? Anything common between 0 and 1? No. They are different, so ignore.
Okay.
So that's the term for the first group. Now go to the second group. Horizontally, at the top, we have 0, 1 and 1, 1. 0, 1 and 1, 1. What is common between 0, 1 and 1, 1? Which bit is common, is the same between both of them? The B. Excellent. B is 1 in both of them. So we only write for B. Ignore the first one because it's different. So B, we are not done yet. Now we need to look at the other side, which is the third variable. Yes, what is it? Is it 1 or 0? 1. 1 means no bar. So you need to write the variable next to B with no bar, which is C.
Oh,
C with no bar. Now you need to add a plus between them because this is sum of product.
oh, okay.
This is the equation of this question. Excellent. Understood?
Mm-hmm.
Clear? Remember the trick to look at those 2 numbers. What is common between them? This is 0, 1. This is 1, 1. So only this bit is unchanged. That's why we allow with single change all the time. Here, no change in the second variable. Both of them are 1, 1. Here is 0, here is 1, so it's changing. Ignore that. We just go with the variable that remains the same. Yes? Here? Yeah, we count it. We count the common only between, because considering this group. So we have 2 ones, and each one of them has its own term. So for this one, we have 0, 1, 1. For this one, we have 1, 1, 1. Right? So for this one, we check what is common in these 2 variables. Why we look for common? Because that common is representing both variables at the same time. Okay? So what's common between both of them is the second variable. And here we have A, B, C. So you could, to not get confused, just change this into A, B, C. This is A, B, This is C. So what is common between this and this is this variable, which is B. Is it 1 or 0? 1, so no bar. So we add B only. Now we go here. We're done with this side, the horizontal side. Now we go to vertical side. Don't skip. And vertically, do we have any circle here? No, the circle is only at the bottom. So we only represent this value. This is C. Is it common in both of them? Yes. C equals 1, represent both of them. Since it's 1, no bar. We just add it like that. That's the term representing this whole group. That's the term representing this entire group. And remember, this is sum of products, so we just add a plus over there. This one. Okay, now forget this one. Now we want to solve for this group. Okay? Remember, we go to horizontal side or the top first, and then we go back to the vertical side. Now, in this side, where do we highlight? Do we highlight this? Do we highlight this? Do we highlight that? That? We only highlight this column, right? So we're only interested in these two. So both of them are representing those two values. So there is nothing common to check. Both of them are common. So we take both values, both variables, because all of them, this and this, are common in these two. Okay? If it is going horizontally group, then we check multiple of those. But this is vertical, so it's represented only by this side. Now, this one A, this one B. This one 0, so we need to add a bar. That's why we have A bar. This one is 1. No need to add a bar, just B. Now, we are not done. We finish this side only. We go again vertically. What is the value C in both of them? No, in this one, at the top, C is 0. In this one at the bottom, C is, since it's different and nothing common between them, ignore it. So no C in this term. Done. Then that term representing this whole group, that term represents this whole group. It's coming on the way. I have a lot of examples to cover. We will see it over and over again. Let's move on. Any question? Yes, go ahead.
You just covered the horizontal.
Up to you. Up to you. Doesn't matter which is which. From the theorem, we know that if this is first plus this one second, same value, right? This is also in algebra. 5 plus 3 is 3 plus 5, right? Doesn't matter which one you start first. The only thing matters, these rules. These rules. That's the only thing matters. These rules. We will see them. So hopefully you'll practice them. Skip over here, skip. No, we didn't solve this. Which one you solved? This one, right? Yeah. Yes, it's this. This is the first group. Second, that's the answer. Okay. Now let's go with the second example, the third one. Third one, based on this. Let's see it together. To raise those ones. Guys, the whole course is about practice. If you don't practice, if you don't solve examples, it will be really difficult. Sometimes it will confuse you more. Do we have ABC? Yes, okay, we can keep the variables. I need a volunteer. Whatever I explain, you'll still confuse, but when your classmates solve it, you'll find it easy. Anything? You already solved, you already solved? Yes, please, come. You're next. Remember those indices just to help you. You don't need to write them in the K-map. Which color? All right, so based on the first index, means row number 1 in the truth table. What is the output? 1. So please insert over here 1. Excellent. Now, row number 2, what is the output? 0. Excellent. Then, what is the number 3? Excellent. You jump and then come back. Remember what she is doing. She's jumping, then coming back. And then number 5. 1, 2, 3, 4, 5 is 0. Number 6, 1. Number 7, jump, 1. Going back, 1 again. Now we are 8. Where is 8? Which is ending with the zeros. So we are here. Now with the purple. Number 9, 1. Number next is 1. Again, 1. Then 0. All zeros now. All of them zeros. 0, 0, 0, 0. Excellent. Amazing. Do you see how she jumped twice? She jumped over here horizontally. She jumped also vertically over there. Now, if you make any mistake over here, it will propagate. It will continue with you, that mistake. It will result in wrong grouping, wrong equation. I will not penalize you for that, but please pay attention, okay? All right, now we need to build the groups of those sizes, and we go with the largest possible, always. For example, can we have a group of 16 ones altogether? They should be next to each other. By next to each other, we are allowed to do the corners together, for example, because this is really like donut shape, torus shape. Where are the ones that we can group? Excellent. Wait, maybe use different color. It will be a mess. Maybe, try your best. Says premium, I don't know. Excellent, that's the first group. Why you choose of size 4? Can't you do 8? No 8, so this is the largest possible. So we go with 4 ones together. Now this is one group. What else can you do? Look at the corner. Wait a minute before you group. Decide, think twice. Yes, those can be grouped together. Excellent, group them. I think you use different color. It's dying. So we group these two together, yes. What else? Look at the corner. No, wait. These two together. How about the other corners? Yes. So all of those are next to each other. And we go with 4, not 2, because all corners are connected together. It's really like cylinder, but also cylinder horizontally. That's what builds the torus shape, the donut shape. So all of those are one group. All the 4 corners, one group, because 4 larger than 2. Okay? That's the only trick in here, which is looking at the corner. Sometimes 1, 1, 1, 1, only 4 ones, sometimes 8 ones. So you have 2 ones over one corner, another 2 in another corner. So you build 3 groups. Now we left with single one. Can we have a one circle with that one? Can we have only group with single one? Yes, but since there is 1 next to it, so we could build of 2 ones. So we go with 2, not with 1, because 2 is larger than 1. Always go with the largest possible. What's your name? Queen? Queen Row. Okay, Queen Row. Queen, right? That's better. Huey. Huey, okay, Huey Row. All right, how many groups we end up? 4 at the corners, that's 1. And then 2 at the corner, that's 2. And then 1 in the middle, and then those 4 ones. So we have 4 groups. Then how many terms? 4 terms. Each group represented by 1 term. And then we add plus between all of those. Do you have any question on how we group? Yes, please. Do we have 3 in this sizes? This is the possible sizes. You cannot invent your own size. Either 1, single one in one group, or 2 ones, 4 ones, 8 ones, and so on. Keep going. You always give priority to the largest possible. Yes. These are through ones, right? The only way to go, split them into two groups. So you go with 2 together and 2 together. No, you go with one corner, that's single one. You cannot make it in a group. Okay. So do you ask for these 2 ones and this one? This one by itself? No. If there's one here, one here, one there, right? This is what you're saying. If here, you would circle those together and those together. Because remember, the corners are connected together. So this, you wrap it around like a cylinder, but also this, you wrap it around like cylinder. So this is connected to this. They are next to each other. So you would group these together, and you would group these together. Okay, yes. Two ones. Group all of them together in the same group. Because they are connected together, so the 4 of them in one group. No, it's never, because it's torus shape. It's not really cylinder. It's cylinder in both shapes. As we saw, where's the donut? This one. I know it's hard to imagine. That's why I asked Gemini to build it. You will not see this shape anyway. It's really nice to have Gemini. So it's really like torus because this one is wrapped around to here, but also this side is wrapped around to down. And this is what we have. Diagonally to where? These and those? No, you cannot do that. Because it will be difficult for you to take anything common. This and this, what is common in here? What is common between here and here? It will be a bit different, okay? Yes, yes, exactly, exactly. If you want to go with product of sum, you go with zeros. We are solving this by default, sum of products. So we look for ones, exact same as we did in the past, nothing different. We look for the ones in the output, and then we try to produce those terms. And this is exactly what we are doing. We are looking for ones, and we try to represent them by terms, but we are grouping here. That's the only difference. I don't want to go through product of sums because it will confuse you more. Let's get solid foundation in sum of products, and then we move on to something else. Yes, what's your next question? Sum of product by default. By default, sum of product. The entire course, by default, sum of products. Okay? Because it's more natural in terms of algebra equation. All right, let's go with the equation. Yes? No, they're not connected together. No, yes, these two, yes. They're not connected. They were, number 10 is connected with 2. 10, do you see number 10 in green? The green indices. Yes, 10 with 2. This 10 with 2. And this 4 with 12. It's not connected with 10. It's connected with 12. Because you wrap it around like cylinder. So second from here will be connected with second from here. 1 from 1, 9 with this with this. Okay? Yes, now choose any group, random. Any group you choose. Corners, excellent. Let's look at the corners. What is common between columns wise? The first column and the last column. What is common between the bits in the input? The second 0, which is B. And because it's 0, we add a bar to B. So it's B bar. We done horizontally, right? And we go vertically. Vertically, first row and last row. What is common between those numbers? 0, 0, and 1, 0. Excellent. D, but it's zeros. Then we need a bar. So D bar. Done. That's the term for the whole group. Now plus. Add a plus. Now, a next group. What is a next group? Choose anyone. The big one, the blue, right? Okay, so we have this column and this column. What is common between this and this? A, excellent. And it's 0, then it's A bar. Done with these two columns. Now we go in this row and this row. What is common between 1, 1 and 1, 0? 1, which is C. C is 1, then no need for bar, right? Just C. Now add a plus. Choose any group you want. This one, okay, vertically. This is 0, 1 only. We don't have other thing to compare with, right? So we need to write both of them, both variables, A, B, but whenever it's 0, we add a bar. So A bar because 0 and then B. And now we are not done yet. We are still in the same group. Now we look at those two. What is common between both of them? D, excellent. And D is 1, not 0, so no need for bar. Are we done? Not yet. We have one group. Yes. Now, over here, this is the only thing common, so we need to write both of the variables. A, B, but there is B with 0, then bar. We're not done yet. We look over here, 0, 0, and 0, 1. What is common between both of them? C. And it's 0, then we need to bar. Excellent job. Amazing. Thank you so much. It's really great work. You deserve 2 bars, not 1. But not today. Okay. Any questions so far? I know it's getting harder and harder, but you need to practice. That's why I prepare a lot of examples for you. We are going to spend 10 minutes more. So excuse me if you have something, you can leave, watch the lecture, but please stay focused for 10 minutes. We will have more examples, and then we can finalize the chapter. Right? Is it the same? Yes. All amazing, all perfect. Where's the equation? This is the equation. Again, the order of those terms does not matter. Yes?
So will the truth table always or
Yeah, I would make it easy for you. I will give you the truth table. But even if not, I would give you a simple question like if a student going to a restaurant, he will not eat. But most probably I'll give you the truth table. Okay?
okay. That was just okay. Let's see the 16. Gotta solve the entire truth table first, and then immediately go to the K-map.
And that go back why we're studying the theorem. You see, here's the pain. It's not easy. It's systematic way. Yeah, there are steps to follow. There is no magic. Yes, I agree with that. So it's easy in that sense. But there is more work to be done over here. Over there, simplifying using theorem, there's no need for truth table, no need for K-map, no need for all of that stuff. You just use one of the theorems, solve, done. Okay? All right, another example. Now I make it easier for you. No need for truth table. I just fill it for you. Exact same mechanism as in there. Now we just need to solve and group the ones. But remember, those indices are extremely important. Okay. Now over here, everything in red is the output. Remember, this is what we need to fill in the table, not the input. The input is already in the top over there. This is the input. Those are the output. Now we need to look at the output. Whenever it's 1, we need to circle them, group them, based on those sizes. Those are the allowed sizes. Yes. Want to help? He will solve. Yes. Come, get ready. Yes.
How can
Doesn't matter the output and input. Doesn't matter. There's no connection. It only depends on the question. Which color?
Yeah, is that on that board or?
Good question. Yeah, please, please. I think easier maybe to raise everything.
Raise these two.
You have a nice way. Yeah, he's smart. He's looking at the ones where to keep and where to remove. Yes, back to your question. There's no relationship between input and output. The input is just in this condition, when all switches are off, I'm going to turn on the light. That's a question, okay? Same as when we said, when a student going to restaurant is going to eat if these 4 conditions are not met, okay? It could be this scenario. For example, A, it could be there's no water. B could be they don't have that meal. C could they don't have the other meal, and so on. So all those conditions are off, 0, 0, 0, 0. Then I'm going to eat. So eating is 1. This is, okay? So output and input are based on the question that's given to you. Good?
Only 2 groups. Largest one is the corner.
Or you already solved it.
Yeah, and then the last one is the one up there. Top one.
Excellent, excellent.
The only
You see, he solved it like in a few seconds. 2 seconds done. He connects those corners all together. Remember, we don't connect this and this together and this together. No, you can group them together because they are real next to each other. So we have 4, and then we left with only this one. We cannot group it alone because there is 1 next to it. If there is no ones next to it, yes, you can go with that size of 1. But since we have 1 next to it, we can group them together. And remember, any one in this K-map can be at least in 1 group, at least, not at most. The same one could be in many groups. That's no problem. Excellent. Now we need to write the equation. Do you want to go with the same color? You can go ahead. Pick a group. You have 2 groups. Which one you start first? Okay, the corners. Look at the column. Column and column. This value and this value. What is common between them? So I have 0, 0, and 1, 0. What is not changing between the 2 values? Yes. Excellent. Which is the second variable, which is b, right? And since it's 0, not 1, then we need a bar on top of it. So b bar stop. Now we are not done. We finished these columns. Now we want to go row-wise. This row and this row, since they have the 1s. Now here 0, 0, here 1, 0. What is common between both sides? It's not changing. D, excellent. And D is 0 in both of them, so D bar. Done. No, don't connect the bars. That will be different meaning. That will be De Morgan. But if the bars are split, another meaning, totally different than a bar on top of all of them. Excellent. We're done with the first group. Now second group, where is it? Here. So look at the columns first. 1, 1, and 1, 0. What is common between them? The first one. And do we need a bar on top of it? Why? It's 1. Excellent. Now we are done with those. Let's go this way, this side. We only have this, right? Because those 2 ones are horizontal, not vertical. So since there is nothing common with another thing, so we keep both of them. So we add all of it. C, D, but both of them are 0, so we add bar to each of those variables. Done. Hopefully it's getting easier now. More clear? Excellent. Thank you so much. This is the first group. Second group is my hand drawing. Hopefully it's nice. Let's go with another example. Oops, I have the solution for you. No, it's correct. This is another example. Oh, because they didn't clap. Yeah, everyone cheer him. That's correct. Perfect. All right, another example. I need a new volunteer, please. A volunteer, please. Yes. You can. Which color? Raise what is needed. So we have 4 ones at the top. You have, yeah, you can keep the corner. but not the other corner. Delete the other corner. So we have 4 ones, 2 ones, and only 1. So delete this corner. Add these two. Please pay attention. This is a bit tricky to group them. How we would group these. So as you can see, there are no 4 corners. So you cannot group the 4 corners. I think you are missing this one. This is 1. So we have 4 ones at the top, and then 2 ones, and then only 1 over here. Yeah, you could solve yourself directly on paper. Just have a piece of paper, practice yourself. Go quickly on that. Yes, now it's correct. Now group them. You can delete the things, the drawing over there. Yes, and delete this one. Yes. Yes, but they should be nearby. They should be next to each other. You cannot group something far, unless the corner. The corner, yes, they are connected together. They are next to each other. So we need to look for the nearby ones and then try to group as one of these sizes. Yeah, now please start grouping. What you would choose. Excellent. That's 1. Have large number of 4s. This corner. No, you cannot connect that. Those diagonally that do not connect. But 10, this one is connected with this. And this is connected also with that and connected with this. So you have many options. This one is connected to that side. It's natural, right? You can imagine it as cylinder. So you bend this hole as a paper, then it will be connected next to each other. Yes, exactly. Can we make it larger? Think about it. So how many ones next to each other in that row? In that row. In the entire row. In the first row. How many ones in the first row? 4, right? No, you said 2, 3. So since we have 4 ones in the first row, just to group all of them, right? You don't need to group the corners. So delete what you did for the corner to not get confused. Remember, we always go with the largest possible. If you choose 2, always ask yourself, can I convert that group into 4 ones? If so, delete that and go with 4. Same thing with 4. Can I go with 8 ones? It's unlikely, but it could be possible. Okay? So as you can see, there are 4 ones next to each other. So we can go with a huge group. Now we are done with those ones and those 2 ones. Now we only left with that one. Can we group it alone? Of course. We have a group of size 1. But can we do 2? Where? This one is next either to this side or next to this side. This one is not 1, so this is 1, so we can group this with that. Yeah. You can get the edges outside, so it will be clear for you that this is a separate group. Yes. How many groups we end up? 3 groups. Excellent. Now erase the equation at the top and build your equation. Do you have any question on how we group? It's a bit tricky, this one, because we said, oh yeah, look at the corner. We try to highlight them, but no need for corners here. We just highlight the whole thing. Yes, please. The edges are horizontally connected and vertically connected, but you cannot go diagonally. So a cell at the top is connected to the one at the bottom, but also connected to the one at the end, because horizontally connected, vertically connected, but not diagonally, not anti-diagonally. Why did we stop at the first one? Which first one? Zero, zero, zero. Yes, this one. And 0, 0, 1. Yes. 0, 0, 0, 1. This one. Yeah, this one is not connected in any way with this one. That's true. If we can group as 3. But there is no size of 3. So what you are saying, why not connecting this one with these two? There is no size 3. Either 1, 2, 4, 8, and so on. There is no group of size 3 ones. Cannot have 3 ones. Either 2 or 4. No 3. That's which group did you choose? The 4 ones. Okay, the 4 ones. We look at the columns. What is common between 0, 0, and 0, 1? A, and A is 0, so we need a bar. Excellent. We're done with this. Now, not yet. We have to go with this. What is common between 0, 0, and 0, 1? C, and C is 0, so we need C bar. Done with the first group. Don't connect them together. Make it clear it's not connected. Yes, now plus, because sum of products. Now, another group, which one? The whole thing. What is common in all of these? A bit tricky. What is common? All of them. Let's see, is the first one being 0 common? No, here we have 1, 1. Is the second one being 0 common? No, here we have 1, 1. Then nothing common. Ignore the entire thing. The entire thing. Now done with this side, go vertically. It's only 0, 0. This group only represented by 0, 0. Nothing in here, right? Because it's not going to span vertically more than one row. It's only entire row over here. So only 0, 0. So we need to have the two variables together, C, D. But both of them 0, so we need bar, bar. So C bar, D bar. Yes? Because done, no more ones. No more ones. No, we don't have corner over here. This corner is missing, no one. Because we could go with 4, which is greater than 2. Why would go with the corner if we can include both ones in a larger group? So both of them, this one and this one, already included in this entire group, right? Done. No need to create another group, which is already included in the larger group. A, B, C, because A, B are not common. Sometimes 0, sometimes 1, keep changing. So we cannot take anything common. Just ignore. You could go with A, B, and all this stuff, but you are adding more terms, which not making it simplified. You'll end up having, oh, I wonder, there is A bar here and there is A here, so we could take them together and simplify with 1 and so on. That story. All right, excellent. We're done with these two groups. Now what is left? This and this, right? So we look in the same column where they exist. We have 0, 0. Anything common? Both of them. Okay, so we write here A, B. But since both of them are zeros, then it will be A bar, B bar. We're not done yet. We look at this side. We have 0, 0, and 1, 0. What is common between these two numbers? D, excellent. And D is 0, so we need D bar. Is it correct? Yes. Good job. Here, we have a mistake that we are not ordering this. Remember last time we said it's better to order them in alphabetical order, right? But it's not wrong. Excellent. Thank you so much. Any question? Of course, if you are doing bad job. If you are doing good job, you should not. Why you're not doing second row? You mean these two ones together? You always, that's good. That's not wrong. You can go with a group of 2, but you always ask yourself, can I expand it into 4? Then you look in the neighborhood. Do we have ones? No, no, no. Oh, I have 1, 1, 1. I have 3 ones. I have 2 ones. Can I expand this into further? If I have size of 5, then I could group all of those together like this, or I could even go further with grouping all of those. This is 4 and 2, 6. Do I have 5 or 6? No. I cannot group 5 ones or 6 ones together. But here, I can group with those two together. So I go with 4 instead of 2. So I don't want to group these separately because it will be a smaller group. And then remember, any group you're creating, you're adding more terms. It means you're not simplifying. You are increasing the complexity of it. If you want to make it least number of groups, and those groups should be the largest possible. Okay? Good? Yes, please.
I'm still stuck on how we're the equation, how we're building it.
Which one? Which equation?
Just like
For example, this entire thing. Here, there's nothing common between these 4 numbers, right? Ignore. We look, this entire group exists in these 4 columns and in this row. So we only check those because it exists in all of them, and we check only this because it exists in first row. Doesn't make any sense that you're checking this number because that group does not exist in here, in this row. It only exists in this row. So when we have this situation and we have only that number, not 2 numbers to compare with, so you consider all of them. This is representing CD, but because 0, 0, we need to represent as C bar, D bar, because this is how min-term works. Okay? And then this group, entire group, will be C bar, D bar. That's it. Let's take another example. This whole thing, 4 ones. Now we look, where does it exist? In column 1, column 2, row 1, row 2. So let's go column wise. This and this, what is common? This and this being 0, it's common in both situations, right? What is the first one? Is A. Since it's 0 in both situations, then it should be A bar. Done column wise. Let's go row wise. Remember, this group only exists in these 2. So this is where we should look. What is common between this and this? First digit being 0 is common, right? What is first digit? C. And since it's 0, we need to add bar. So we have A or A bar and then C bar. And keep going like that. Yes, please. Verse 7. Yes, excellent. Then you have 2 ones and 2 ones. You could group all of them together. What is the 8? 6 and 2? Yeah, those will be 4, right? One group. And this and this and this and this, one group. Okay? Those 2? No, these 2, you can connect them only with those 2. Or with these 2. So this is where the neighborhood is. Either you cannot connect this with this. If you add all of those together with these 2, that will be 6 ones. No, not 8. So 2, 2, 2, and 4, right? That's a good point. Let's see. I don't think it will work.
yeah, why
I don't think it will work.
would the yeah, like you think of it like first by column?
Oh, guys, before we end up, the last thing. There is a group, very nice group. Now we will try this idea. We will see it. There is a nice, very nice website. Give me a second. Sorry, this is just for your benefit. Let's go over it together quickly. Where is it? Sorry, just give me a second. Yeah, if you type in Google Karnaugh map solver, you get a very nice tool, an extremely nice tool visualized, where you can randomly assign ones, and then you'll see the grouping. Okay, and you can change the variable. Let's go over it together quickly. It's extremely slow. Okay, just give me 1 minute. I'm going to send it in iCollege. But just to motivate you, all right. So this is one of them. This is the nicest I find online. I'll send you the link later on, but you choose Karnaugh map over there, and you go with how many variables you want. It's up to 5. 5 means 2 of those copies, right? And then the nice thing about it, if you go to here, you could highlight any cell you want it to be 1. For example, we want this and this. Now let's do the example. The scenario you mentioned, something like this. Doesn't work. It should be really a regular shape, rectangle shape, or square shape. Yes?
In,